Question number 3 is find the equation of a line in the figure shown below. We've seen them in slope-intercept form. We've seen solutions in standard form. This one has to be a solution set that is in the x and y intercept form, not the slope-intercept form, but the x and y intercept form. So one of the things that we know for sure, and there's a couple different routes to go, and I'll show you both routes, but one thing that we know that we can do is we can always write our most basic one, and that is our slope-intercept form. We definitely know what our slope is. We have to go up 4 and right 5. Up 4, right 5. That is a 4 to 5 ratio for slope of x, and then our y-intercept is a -4, so -4. So if this were the answer choice, that would be easy. We get one that's fairly close, but the sign of the slope is wrong, so that's not correct. We know that D can't be right because that slope is wrong. So when we look at our other 3 alternatives, they all have this common formula that's set equal to 1, and the x's and y's are on the same side. So what we want to do is we want to force x and y to be on the same side, and we also want to make sure that we get the 4 to get turned into a 1. So I'm going to do a couple things here. I'm going to move the y to the right and the -4 to the left. So that's going to give me 4 equals 4/5 x minus a y. Next thing we want to do is we want to make sure that this constant over here is a 1. So to do that, we're going to have to divide it by 4. Well, dividing by 4 is the same thing as multiplying by 4. So that's what I'm going to show here. I'm going to multiply both sides of this equation by 1/4. So 1/4 of 4 is 1. If I take a 4th of 4/5, I'm going to show that a little bit more detail, times x, minus, and a 1/4 of a negative y, which is 1/4 of y, so 1/4 times y. And then I can work with these fractions. So I got 1 equals, the 4 is going to cancel, so that's 1/5 x minus 1/4 y. So now what we can do is we can get an exact same format they have. They can go 1 times x is x, so x over 5 minus y over 4. And this is what they call the x and y intercept form. This form is very conducive to finding and locating the x and y intercepts very quickly. Which kind of brings me back to another way of doing this. If you wanted another alternative, when you start running into some goofy things that you haven't seen before, you can look at this ordered pair at the y-intercept that's ordered pair 0, -4. We also know the y-intercept is, or the x-intercept is 5, 0. And you can start looking at plugging your values in very quickly. Since we have zeros, it works really quickly. So, but this ordered pair, if I plug in a 0 for y, that puts a 0 up here. So that's going to eliminate this. And that means our x value would have to be, if we multiply times 5, x would have to equal a 5. And that's exactly what we have. I also want to make sure that this equation satisfies it for the y-intercept. Well, the y-intercept is 0, -4. So that means if I put in a 0 for x, that would force the y value to equal a -4. So then we multiply both sides times a -4, and y is a -4. That could be another approach just by testing your points of your x and y intercept into your equations that they give you, and you can quickly reconcile it. But if you're well-versed, and we're not well-versed in this intercept form, you can see, if I clear up some of the clutter, what you wanted to be able to do is put your x-intercept, x over your x-intercept, so x over 5, your y over your y-intercept, which is y over -4. It's always equal to 1. So that would be a really quick way of doing it. But we don't have a lot of connections that way, so I had to build bridges a different way into this problem. So pick your poison, whichever way seems to make the most sense to you.